Good morning, students. Yesterday we have already discussed about real numbers, Euclid's division lemma and Euclid's algorithm. To add further, today I am going to discuss some questions from your exercise 1.1. I hope you will understand all these questions. So, let us start with question number 2. Question number 2 is, show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. So what we have to show? We have to show that about the any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Now you have already discussed about the Euclid's division lemma. So what Euclid's division lemma says? It says that given any two positive integers a and b such that a is equal to bq plus r, where 0 is less than equal to r is less than equal to b. We already know that. Now if you look at these integers 6q plus 1, 6q plus 3 and 6q plus r, they are of the form bq plus r. So here one thing is clear, that we will take b as 6. Now let us start our solution. Let a be any positive integer and b equals to 6, because this is given. So by Euclid's division lemma, what we can say? We can say that a equals to bq plus r, where 0 is less than equal to r is less than equal to b. Now look here, Ra is 6. So let us put this value. Rb is 6, sorry. So a equals to 6q plus r for this question, where 0 is less than equal to r is less than equal to 6. What does it mean? It means that our remainder, it can be 0 or it can be greater than 0, but it will be less than 6. Therefore, possible values of r are 0, 1, 2, 3, 4 or 5. R can take these possible values because R lies from 0 to less than 6. So maximum R can take value 5. Now when R is 0, what does A become? A is equal to 6q plus 0, or we can say this is 6q. When r is equal to 1, a is equal to 6q plus 1. When r equals to 2, a is equal to 6q plus 2. When r is 3, a is 6q plus 3. When r is 4, a is equal to 6q plus 4, and similarly when r is 5, a can be 6q plus 5. Now look here, see one thing. When a is equal to 6q, that is when remainder is 0. Here q can take any value. So let us start with this first equation. A equals to 6q. So if q is 1, what will a become? A can be 6 into 1, 6. When q is 2, a can be 6 into 2, 12. When q is 3, a can be 6 3s are 18, or when q is 4, it can be 6 4s are 24. And similarly, you can continue. For all values of q, our a will always be even. So what we are getting here? We are getting a to be even number. This will be an even number. Now, when our remainder is 1, so a takes value 6q plus 1. In all these cases, for any value of q, our a will be odd. Why it is odd? Because let us add here 1. 6 plus 1, it will become 7, odd. 12 plus 1, 13, odd. 18 plus 1, 19, again odd number. 24 plus 1, again odd number. So when remainder is 1, a takes value 6q plus 1, which is odd. When remainder is 2, then a can have values 6q plus 2, that is 6 plus 2, 8, 12 plus 2, 14, similarly 18 plus 2, 20, or 24 plus 2, 26. That is, in each cases, for each value of q, a will be even only. For next part, if r is 3, when remainder is 3, for all values of q, our a will be odd again, because when you will add in 6 3, it will become 9, an odd number. 12 plus 3, 15, an odd number, and so on. So here a will be odd. Similarly, in next case, 6q plus 4, a will be even only. You can take any values of q, and for remainder r equals to 5, our equation a equal to 6q plus 5 will be odd only. All values will come out to be odd only. So what do we see? We see here that for a equal to 6q plus 1, our number is odd. For a equal to 6q plus 3, numbers will be odd, and a equal to 6q plus 5, our numbers will be odd. So what can we see? So here we can see that for any positive odd integer, so we can see here that any positive odd integer is of the form 6q plus 1, 6q plus 3, or 6q plus 5, where q is some integer. So what we can write? Therefore, any positive odd integer is of the form 6q plus 1, 6q plus 3, or 6q plus 5, where q is any integer. Whether you give q any value, this value will always be odd. Similarly, 6q plus 3 will always be odd, and 6q plus 5 will be always odd. These will come out to be odd integers only. So with this, our first question ends.